All right, so today we'll look at section 8.2, and that'll finish up what we're going to be doing as far as solving right triangles. We're also going to look at the very end area of a triangle, and I'll show you the connection between that and law of cosines. So LOS is law of sines. So that's what I just summarized for you on the board. Those are the three types of problems we've done so far. Well, the two other types that we can solve can't be done with law of sines. Okay, remember, to use law of sines, you have to have a full row in the table. Well, there's two different cases that if I start to fill out the table, I won't have a full row. This is one of them. Side, angle, side. So if you started to fill out your table, 3 sides, 3 angles, the way side, angle, side could look is you would know this, this, and that. So you have no way to get the third side directly because you can't use Pythagorean Theorem. And if you try to set up law of cosines or law of sines with a problem like this, remember, you always have to pick 2 rows. Well, if you pick the first row and the second row, you're going to miss 2 things. You can't do that. You can only be missing 1. If you say, all right, I'll try setting up law of sines with row 2 and row 3, you're still missing 2 things. Last thing you could try is, well, I'll pick row 1 and row 3. Jane, can you just shut that for me? Thank you. If you try row 1 and row 3, it still doesn't work because you're missing 2 things. You can't be missing 2 things at the same time. All right. So that's an example of side, angle, side. Okay. What makes it side, angle, side is you know 2 sides, but the angle that you know is in between the 2 sides. It's where the 2 sides meet. So that's one way we wouldn't be able to solve with law of sines. Does anyone remember the other type I mentioned? There's one other. So look at the ones we've done and the one I just showed you. There's one more arrangement of letters. Yeah? Well, if you had angle, 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 you wouldn't be able to solve that. How come? Like if I said to you, all right, let me think of a simple problem. I'm thinking of a triangle in my head, and the angles are 60, 60, 60. So it's an equilateral. Tell me how big each side is. But all I'm telling you is the angles are all 60. Yeah?
You won't be able to create the correct triangle because you'll only be able to create similar triangles. And the
right.
way you will solve it is by guessing the correct number randomly.
So if all you know is the angles, you could find one that's similar, but you need a side. No matter what type you do, you've got to have at least one side, sometimes 2. Sometimes you could even have all 3. Side, side, side. So if you had all 3 sides and you fill that out in your table, you're going to know everything in one column, but you're going to be missing everything in the other column. You're going to have no rows that are full. So both of these 2 problems would involve law of cosines. Any questions on that? So those are the 2 we'll focus on. Also, you don't have to worry about 2 solution, no solution, and all that stuff. You're always going to get 1 solution with the law of cosine problems that I give you. Right, so let me actually start by giving you the law of cosines. So there's different versions of the law of cosines depending on the information that you know. Every version follows the same pattern. Okay? I'm going to show you how the first version starts out. C squared equals a squared plus b squared. Does anybody recognize what that looks like right now? We have a little bit more to add to it. Right, kind of looks like the Pythagorean Theorem, but we know the Pythagorean Theorem only works with 90-degree angles. So there's something here on the end you need to subtract. And think of this as like an adjustment to the Pythagorean Theorem. It's adjusting the theorem for the fact that you don't have a 90-degree angle. And what you have to subtract is 2 times the letters that just came before. A, B. A, B. And now this wouldn't be law of cosines if you didn't put the cosine in it, and that's the last thing in the formula. Cosine. And how do you know what angle to pick? It's always the angle across from the very first letter you started with. So what Greek letter is across from C? Gamma. So the pattern, no matter what you call your sides, is basically one side squared equals the sum of the other 2 squared minus twice the other 2 that you just wrote, and then cosine of the angle across from the side you started with. So let's try writing it with b squared. Okay. What do you think would come next? B squared equals, if it follows that same exact pattern, just going to be different letters. So these are sides. So the only angle is going to come in at the very end. That would be the first one. Yep, a squared plus c squared minus 2ac cosine beta. Yes. So basically, this is your pattern. Something squared, something squared, something squared. Just like the Pythagorean Theorem. Minus 2 something something cosine something. You just fill in those 1, 2, 3, 4, 5, 6 boxes. So let's fill it in for the version that begins with a squared. What would go in these 2 boxes? B, C, these 2 boxes? B and C again. So it's like you put in the same letters. And then in the last box, alpha. So you don't really have to remember all the different versions, just remember the pattern that I kind of showed you with the boxes. Okay? And that's the law of cosines. We're just gonna use the formula. We're not gonna go through the proof, but you can probably guess what theorem is involved in the proof. The Pythagorean theorem. Now, even though we're learning to use this formula on triangles that don't have a 90, you can use it on triangles that do. We just have easier ways. We usually use SOHCAHTOA, opposite, adjacent. We usually use that on a right triangle because it's faster than this stuff. But all this stuff still works on right triangles. It's just kind of like using a toothbrush to wash your car. It takes too long.
So you can still use that formula to find side, side, side?
Yes, you use this formula for 2 things. Side, 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 and side angle side. Yep. And we're going to go through one of each. So if you tried to use this formula on a right triangle, that would mean you have an angle that's what? In a right triangle? 90. So pretend that that angle was 90 and you tried to use this formula. Watch what happens. Take the cosine of 90. You get 0. What's 0 times 2 times a times b? 0. So in a right triangle, what happens is that whole part just cancels out, and all you're left with is really the Pythagorean theorem. When this angle is not 90, this part will not be 0, and then we need it. Okay? All right, so let's look at an example. So 2 main types. This is a side angle side. The next one we're going to do is a side, side, side. when you have side angle side, you have to find something first. When we do the side, side, side problem next, you can do anything you want. Doesn't matter. Okay, but we'll do that one next. So if I put up the formulas at the same time, let's just call this version 1, version 2, version 3. There's only one version of that formula that you have enough information to use. You're already missing C. C is in every version of every formula. There's a C here, C here, C here. So you can't use a version of the formula where you're missing anything else. So which version would you have to use? Yeah. You have to use version 1 because you've got to use this angle. And the only spot for gamma is in version 1. Okay, so let's plug it all in. C squared, A squared plus B squared, 4 squared plus 7 squared, minus 2 times A times B. What's 2 times 4? 8 times B. 8B is 7. What's 8 times 7? 56 cosine 42. Now, there's no parentheses. I didn't write that with any parentheses, so all we have to do is follow PEMDAS. So, order of operations. What do you do next? Addition or multiplication? Do the multiplication. So don't try to do 49 minus 56. You can't do addition and subtraction until you do multiplication first. Right, so that's 56 cosine 42. So that's minus 41.616. Now you do addition and subtraction in order from left to right. So now you can just take that whole thing in. So we got 16 plus 49 minus 41.616 gives me 23.384. This should technically be approximate because we rounded it. It's not an exact answer. Now, how do I get C? I don't want to know C squared. I really want to know just what C is. Take the square root. So I can just take the square root of the last answer I had on the screen. It's about 4.836, and that's C. Okay, let's try it out now. See what we got. So I'm going to put all the information that I had originally plus the information that I just figured out, which was C. So I had A. I didn't have alpha. I had B. I still don't know beta. I had gamma, which is what made it side angle side. But now I also figured out C, 4.836. So with that extra piece of information, what other type of triangle is it now besides SAS? What else? Side, side, side. That's one. Side, side, side. Side, side, side would fall under which law?
Cosine.
It's still law of cosines. There's one more type.
Side, side.
Side, side.
I told you.
Side, side, angle. Or you could look at it side, side, angle. Whichever way you look at it, side, side, angle. Which law does side, side, angle fall under?
Sine.
That's law of sines, but that's the case we don't like. Remember, that's the case where you're going to do all the one solution, two solution stuff. So if you start a problem with law of cosines, I would finish it that way. Technically, if you switch to law of sines, you can if you do it right, but it can be a little tricky. So just do law of cosines one more time. We had to get C first, but now you've got a choice. Alpha or beta. Doesn't matter. It's exactly the same amount of steps. So which one do you want to do, alpha or beta? Or none of them, just stop and call it a day. Okay. All right, we're going to do beta. Well, we could, but then you might get a little frustrated on the test. Or cry, I don't know.
I like that second option.
So if you're finding beta, you're going to use the law of cosines that starts with b. So b squared, a squared, c squared. All right, let's go back. Let's make this all on one page so I can see. B squared is 49. Equals a squared plus c squared. A squared is how much? 16. And c squared, don't take 4.836 and square it. Just look at the line right above it. I already have it. C squared is 23.384. Minus. What number always comes next when you subtract? It's always minus 2. And then it's the two sides you just squared. A, C. A, C. All right, so 2 times A is 8. 8 times C. We need a calculator for that. 8 times 4.836. 38.688. So minus 38 point, what did I say? 688. Second decimal. Cosine beta. Yeah, beta. Now, this one's a little different. Last time, the variable was pretty much by itself. It was already on the left. You did a bunch of arithmetic on the right. This time, the variable is mixed in with everything else. So we have to get everything away from the variable and put it on the left. Okay. What can I do first on the right-hand side? There's a simple thing I can do first. Yep, combine like terms. And what are my like terms here? 16 and
23.3.
yes. Add those up. What's 16 and 23? 39. So 39.384 minus 38.688 cosine beta. Now, a lot of people make a mistake at this step. They try to do something you can't do. That equation right there is basically like this. 49 equals 39 minus 38 times something you don't know. The something we don't know is cosine beta. But if this was your equation, what would you do next there to get x by itself?
Subtract 39.
Yes, subtract the 39. Don't do 39 minus 38. You can't. 39 and 38 are not like terms because of the thing you don't know. Okay, so bring the 39 to the other side. Subtract it. And subtract it. Alright, so we got 49 minus 39.384. Does anyone have what that comes out to? 9.616. Thank you. And then we still have negative 38 cosine beta on the other side. Okay, we've got 2 steps left. What would be my second to last step? Yep.
Get rid of the negative 38.
Yep, and how would you get rid of the negative 38?
Divide it.
Yes, we divide each side by negative 38.688. That's gone. And divide by negative 38.688. Now, when you get to this step, this fraction that I just circled should always have the bigger number in the bottom. Okay. I mean, I know it's the negative, but just pretend like they were both. You have a 9 and you have a 38. The bigger number should always be in the bottom. Okay. Because if it's not, you're not going to get a fraction less than 1. Okay, that's what has to happen right here. This number has to come out less than 1. Okay. All right. So let's write that out. 9,616 over negative 38,688. Now, that's the cosine of beta. I just want beta. So what do I have to do on both sides? Take the inverse cosine. Inverse cosine. Inverse cosine. And there's your answer for beta. So inverse cosine of, type all that in. Okay, so we get second, inverse cosine. 9.616 divided by negative 38.688. Doesn't really matter if you close the parenthesis because you got nothing else coming after it. So you should get an angle of 104.392. Anybody get that when they typed it in? Yep, okay. So 104.392. And that was beta. Now we've got 2 out of 3 of the angles. How can I get alpha with very little additional work? Yeah?
You just add gamma and beta together and that's subtract.
Yeah, just subtract the 2 angles you have from 180. So that leaves alpha at 33.608. Okay, and if I had to focus on one kind of law of sines problem to put on the test between the 2 we're going to study today, this would be the one. The reason is because this type of problem tests if you can do both things. First, it tests if you know how to find a side with law of cosines. Then it tests if you know how to find an angle with law of cosines. When we do the next type, it doesn't test both things. In a side-side-side problem, you never have to find a side. You only have to find angles. So if I choose to not put both problems on the test, I would probably put the last type on because it tests finding a side and finding an angle rather than finding the same thing 3 times. Right? But that's what you're doing here. You're never going to have to find a side. So at a minimum, how many times would you have to set up law of cosines here to solve this problem? 2. At a minimum, you have to do law of cosines twice. Does not matter which 2 angles you pick, but you've got to find 2. Now, if you really like law of cosines and you find it a fun thing to do in free time, you could do the law of cosines 3 separate times, and the advantage would be is if you mess something up, it wouldn't affect anything. So you could use law of cosines to find alpha, and let's say you make a mistake. Then you use law of cosines to find beta. Your mistake wouldn't affect beta because alpha would have nothing to do with it. And same thing with gamma. All right. The disadvantage is if you only do law of cosines twice, and then you add them up and subtract from 180, if you got one of them wrong, the other one's wrong. Can anybody think of the kind of triangle where you would only have to do law of cosines once? If you were given all the sides. Yeah.
Equilateral.
Well, if it was equilateral, I can already tell you what all the angles would be. They'd all be 60. So you actually wouldn't even need to do law of cosines if it was an equilateral at all. But there's a type where you'd have to do it just once, but you're kind of on the right track. Yeah?
You're right. Or like an isosceles.
Isosceles, yeah. If it was isosceles, and say you find one of the sides, then you automatically know the other one too, because 2 of the angles would be the same. And then the third one, just add up the 2 and subtract from 180. So if it's isosceles, that would speed things up. This is scale, so we got to do it twice. All right, let's pick an angle. Which one do we want to find first? Alpha, beta, or gamma? Alpha. Okay, so let's find alpha. How does the law of cosines start if you want to find alpha? A squared, which is how much? 81 equals b squared, which is 49, plus c squared minus 2 times
Oh no, E times C.
BC, 2BC. 2 times B? 14 times 5. What's 14 times 5? 70. You know what? I'm just going to write that in all at once since we did it. So 2 times B times C. Okay so far? Times cosine of, what angle are we finding?
Alpha.
Alpha. Okay. 81. Combined like terms. 49 and 25 gives me 74. Minus 70 cosine alpha. Now, can I do 74 minus 70? No, because the 70 is multiplied by something I don't know. Bring the 74 to the other side. That's gone. 81 minus 74. How much? 7. Equals negative 70 cosine alpha. And let's do both of the last steps at the same time. What's my next step? Divide by negative 70 and take the inverse cosine. So really, I mean, you can shorten this up if you do some of the steps like we did into like 4 kind of steps here. All right, let's see what we got. Second, turn it on. Second, inverse cosine of negative 7 over 70. Now, if you're looking at it and you're like, wait, you put the negative in the top, it doesn't matter. Put it somewhere, top or bottom. Okay, so alpha is 95.739. So now we've got alpha. Now we have a row that's complete. But we want to stay away from, I mean, you could use law of sines to finish this. You technically could.
We can use side angle.
You could, yeah, you could do it as law of sines, but you got to be very careful. So I would recommend just do law of cosines one more time. So usually if I start a problem with law of cosines, that's what I use. Let's do, have we done beta yet? Yeah, actually we found beta. We haven't done a gamma. So let's try the version where we find gamma. Okay. How does that one start? Let me just write this out. Yep, c squared. So we got that, 25, equals a squared, 81, plus b squared, 49, minus 2 times what? Times what? 297. Cosine gamma. All right, and you know what? We actually already squared these as we went, so we don't need those there. If you didn't square them as you go, then you'd have to square them right now. All right, 81 and 49. 130. And 2 times 9 times 7. Well, that's going to be 18 times 7, which is 126. Okay, next up. Yep, and that's going to give me negative, how much? Negative 5? Well, it ends in 5.
Negative 105.
105. You had 1 out of 3 numbers. That's not bad. So negative 105. And the last 2 steps I usually do at the same time. What's my second to last step?
Divide by negative 126 into the inverse.
Yep. And when I divided by 126, I canceled the negatives because negative divided by negative is positive. Inverse cosine. Looks good. Bigger numbers in the bottom. That's where it always should be. And let's see what we got. Inverse cosine of 105 divided by 126. 33.557. And that was gamma. Okay. And now just add them up and subtract from 180, and that is your last angle. So minus 95,739 minus 33,557, and you get 5704 for omega. Okay, so that's a side, side, side. Okay, so any question on the side, side, side or side angle side? Okay.
Can you say that again? I'm sorry.
Any question on what we just did? We're good? Okay. You sure? All right, let's, I think the hardest part with the word problem is really just setting up the diagram. So let's get the diagram set up, but I'm not going to go through and solve it because it's going to end up being a side angle side like we just did. Okay. So it says a surveyor wants to find the distance between 2 points on opposite sides of a building. So the surveyor is standing at another point, which I'll show you in the picture, which is in front of the building. All right? So the surveyor is standing in front of the building, and they can see one side that they want to measure to, and the other side they want to measure to. So we want to find the distance between both sides, from point A to point B. Now, maybe you can't measure between the two houses directly, or between the house, because maybe there's a canyon, or maybe there's a river. So we're trying to find the distance across something that we just can't take a tape measure and measure it easily. All right? In our case, we can't find the distance between the two houses because there's 5 lions. They're lions if I make them bigger. See?
Oh my god.
And there's 5 of them, and I mean, I could probably get past 1 lion, but I don't think I could do 5.
No, I think you got 5 lions now.
So we want to measure the distance between A and B, but we don't want to upset the lions in the middle.
I think you're lying around.
Nate, stop talking.
Yes.
All right, and the surveyor is standing at point C, okay, and they tell us a little bit of information. So they say that the surveyor is 110 feet from point A and 160 feet from point B. That's 2 sides in your triangle. So the surveyor, I think they say it right here, the surveyor is located at point C. Here's your surveyor. 110 feet from point A. 160 feet from point B. Okay, and they would have to tell us one more thing, which I erased accidentally because it was part of it, but I'll put it in words too. Angle ACB is 54 degrees. Without that information, you couldn't do it. Angle ACB is 54 degrees. Now, find the distance from A to B. So, what kind of triangle is this? Using the 3 letters.
Side angle side.
It's side angle side. SAS. Side angle side is which law?
Cosine.
Law of cosines. So, doesn't matter what you call this other side. Call that side on the top x. I'll set up the formula, but then I'll leave it the rest to you. So this would start out x squared equals, and what would come next? 110 squared plus 160 squared minus 2 110 160. Yep. Cosine of the angle across from the side we started with, 54. So now you just do out that arithmetic. Last thing you're going to do is take a square root. But from there, any question on how you would finish that up? It's just like the first problem we did. Numbers are a little bigger, but again, just use your calculator. Okay. So, last thing I said we're going to look at is area of a triangle. So, the basic formula, if you don't remember from geometry, is just 1/2 base times height. We're going to use that right here. So that formula works fine as long as you know the height. Like if you had a triangle like this, you don't know the height in that triangle. If you said that 3 is the height, no, it's not. 3 doesn't go straight up and down. It's kind of slanted. So there's a very easy way to find the area of that triangle. But you can't use 1/2 base times height. But the way we're going to find the area, it's based off that formula. So let's take a look at this problem. Okay. Let's draw just a regular triangle. And I'm just going to label some things that I'm going to need. Let's label the bottom side B. Okay, and we'll assume that they give you B. Okay, they'll give you that in the problem. What they're not going to give you is this. H stands for height. H could also be hypotenuse. We'll try not to mix it up with that. H is height. And let's say that they give us an angle. That side would be A. I'm not going to use A. I don't need it for this problem. What I do need is B. Okay, they would have to give, that's probably a bad idea. We already used B.
Just change B to C.
Make it a capital B.
Okay, I could, as long as that doesn't confuse anybody. That might confuse people, though. You know what? I'll call it B. But instead of that one, let's just call that X. So X is the bottom side. All right, so to find the area of a triangle, you need the height, right? If you're going to use that formula. You need this, but let's say they gave you that and that instead. From the perspective of alpha, which side is that? Opposite, adjacent, or hypotenuse? It's opposite. And from the perspective of alpha, is B opposite, adjacent, or hypotenuse in this triangle? Right there. It's the hypotenuse. Which trig function involves those two? Sine. So the sine of my angle equals opposite over hypotenuse. Opposite is H, hypotenuse is B. Now, how would you get H by itself? Multiply both sides by B, exactly. So here is a formula to find the height if you don't know it. It's b sine alpha. So we could plug that in right there and get a new version for the area of a triangle. Area equals 1/2 the base times, now don't put height, don't put h, put the formula right here. B sine alpha. Now, what's not important is what you call these two letters. You can call them anything. What is important is the pattern. It's 1/2 the product of two sides. X is a side, B is a side, times the sine of alpha. Where is alpha in relation to X and B? It's right in between them. That's the pattern. It's 1/2 the product of any two sides that you want times the sine of the angle that's right where the sides meet. That's the pattern. So you could really write it 3 different ways. Here's the letters we normally use. All right, so they all start out with 1/2. Now, let's do B and C. What angle is right in between B and C? Alpha. So 1/2 the product of two of the sides times the sine of the angle that's between them. All right. What other two letters could I do besides B and C?
A and B.
We could do A and B. Let's do A and C next. We could have done A and B, but we'll do that one last. Times the sine of, what's the angle where A and C meet?
Beta.
Beta. And then the last version, 1/2 the product of A and B times the sine of what angle is between A and B? Gamma. All right. So again, you could write this 100 different ways. I mean, you could write it with X, you could write it with L, M, N. You can write it as many ways as you want. But this is what you really want to remember. The area of a triangle is half the product of two sides times the sine of the angle between the sides. Okay, and the reason I say to try to remember it this way, with what the brackets are at, is because you might have a problem like example 3. I haven't labeled anything in that picture. So how do you know which side is A, B, and C? You don't. That's not really important. Just plug those numbers into this pattern, and you're good. Okay. So no matter what you're using, what fraction do you always put in the area formula first?
1/2.
You always start with 1/2. So 1/2. And what's going to be the next two things I put?
3 and 12.
3 and 12. 1/2 the product of the two sides. And then the last thing I'm going to put?
Sine of 105.
The sine of the angle between the sides. Sine 105. Okay. 3 times 12 is 36. Half of 36 is 18. Type that in, and that's it. That's your answer. 18 sine 105. 18 sine 105. 17.387. Now, what did I just find?
The area.
I just found the area. So how could I make it so somebody looks at that number and they know it's an area? Unit squared. Yeah. And that's it. That's all you have to do. 1/2 the product of the two sides times the sine of the angle between them. And the reason this kind of ties in with law of cosines is because it's a side angle side triangle. It's SAS. Okay. Questions on that? All right, so last problem we're going to do is another area problem. It's going to be this one. Don't write it down yet because I have to show you something first. What's a little different about this one?
We don't have these angles.
You don't have any of the angles. You have a side, side, and side. To use the area formula I just gave you, how many of the angles do you need? One. Which one? Any. It doesn't matter. Any of the angles. Side, side, side. Find one of the angles. We just did that right here. Side, side, 975. In fact, is that the same problem? Yeah, it's the same problem. So 975, let's do it. Now, the only reason this problem is going to be fast is because we already did it. If we didn't already do it, I'm going to show you something else. So let's do 1/2 the product of which two sides? Doesn't matter. 9 and 7. Okay, so that's A and B. So in my head, I'm thinking, all right, A and B. I'm going to go back to my diagram. What side or what angle is where A and B meet? Gamma. So I need to go back and see what we got for gamma. We got 33.557. Sine 33.557. Now, again, not bad because we already did all the work to find gamma. If we hadn't, this is going to take a lot longer. Okay, let's type it in. 1/2 times 9 times 7 times sine of 33.557. So the area of this triangle is 17.412. But there's a better way. Okay, what if you hadn't done law of cosines to find one of these angles? Well, you don't have to. As long as you know all three sides, there's a different formula you can use that wouldn't require you to find the angle. Okay? If you don't want to remember this formula, you don't have to. You can do it without it. I just did. Okay? You can just use law of cosines. But the shortcut, if you don't want to do law of cosines, it's called Heron's formula. This formula is good for when you know all the sides. And you don't want to use law of cosines to find an angle first. So A, B, C. Those are the sides. But there's a letter here we haven't really done anything with, S. And it's kind of hard to guess what that stands for. But if you add up all the sides in a triangle, what do you call that? Well, it would be the circumference if it was a circle, but we call it the perimeter of a polygon. So S stands for semi-perimeter. Semi-perimeter. So all it is when you take all the sides, add them up, and then multiply by 1/2. I think this is a faster way to find the formula for an area for a side-side-side triangle if you're not given an angle to start with. So let's do the same problem we just did and see if we get the same area with Heron's formula as we did using the other one. Okay, doesn't really matter which side is which because you have to do S minus every side. S minus A, S minus B, S minus C. Okay, so let's do this one. What's the semi-perimeter here? So when you add them all up, they add up to 21. That's the perimeter.
And then
Times 0.5 is how much? 10.5, yeah. Okay. And that's the only calculation we have to do before we can start the formula. So area equals, what's the first thing you put in the formula? Put this so you don't forget it. The what? Before we write any numbers. The square root, yeah. so we don't forget it. Now, the first thing we put is S times S minus every side. So let's just do that in our head. What's 10.5 minus 9? 1.5. 10.5 minus 7? 3.5. 10.5 minus 5? 5.5. And now type it in. And hopefully we get 17.412. So square root of 10.5 times 1.5 times 3.5, 5.5. I get exactly the same answer. Now mine's a little different because remember the angle we used, 33.557, it was rounded. But it's basically the same answer, 17.412. So if you have to find the area of a side, do it either way. Whichever way you think is better for you. So that's where law of cosines could come in to finding the area of a triangle, finding an angle first. Okay. Any questions on that? So homework tonight, it's on next section, 443. It's 1, 2, 5, 6, 13, 14, and then 17 through 19. Just a reminder, if you do have to make up any tests and you got to do it after school, Thursday is the only day that I will be here. If you can make it up during the day, you're welcome to come anytime.